Hi there, Teacher Eugene once again, and in our last video, we talked about polygons. Polygon or not polygon, convex or concave, regular or irregular, and we also named polygons according to the number of sides they have. If you take a look around, there is this shape which is not considered a polygon, but it's extremely important that we see it everywhere. You know what that shape is? You're right, that shape is a circle. Today, we will define and illustrate a circle, identify some of its parts, and name the lines, angles, and arcs related to it. A very good example of a circle is a wheel. A wheel needs to be a circle, unless you are ready for a rough ride like this. Do you think it's fun to ride on a square wheel? Well, let's see. You can tell why this kid isn't so happy with his bike. How about you? Can you name things around with circle shape or circles in their designs? Yes, there are so many circles in real life, like a coin, a clock, a CD, a pizza, a dartboard, and even your satellite receiver, to name a few. There are endless examples of circles that we may not be able to name them all. But mathematically speaking, what really is a circle? In geometry, a circle is the set of all points which are equidistant or the same distance from another single point. Let's say we have a single point to start with. Let's name this point point A. And from this point, we will start drawing points which are equidistant from it. This point here is 15 inches away to the right. Now, let's make another point, also the same distance but in a different direction. Let's say down here. Now let's make another one, also 15 inches away, but again in a different direction. Let's say right here, and then one right here, and then another right here, and then let's make one right here, and here, 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 and here, and here, and here. You see, I'm getting tired of making these points, but I hope you're getting where this is going. The more equidistant points we add, the more it shows the shape, which is the circle. That is why we define the circle as the set of all points which are equidistant from another single point right here. Of course, we don't see this as a set of points, because there's infinitely many points being connected together to form the circle. Okay, now let's learn up the parts that make up a circle. First, we have that original point that we started with. That's called the center of the circle. Whatever is the name of the point at the center will be used to name the entire circle. Say in this case, we have point A at the center, so we will call this circle Circle A. A circle is also denoted by this symbol. We can write the notation as, and it is read as Circle A. Next, we have the distance that we use to draw all the equidistant points to form the circle. That distance is called the radius. Even though you can draw as many radius lines as you want, a circle has only one radius dimension, since it's the same length no matter where you draw it. Another important part of the circle is the diameter. The diameter is the distance across a circle. If you start at one point of the circle and then draw a segment straight through the center to the other side, that distance is the diameter. If you notice, the diameter is just two radii drawn in exactly opposite directions. So for our circles, the diameter is always twice the radius. Next is the chord. The chord of a circle is a line segment joining any 2 points on the circle. Now, is the diameter a chord? The answer is yes. The diameter is considered a chord. It is actually the longest chord of the circle. Next are lines related to a circle. Let's say we have a line passing here, and it touches the circle at exactly one point. That line is called the tangent line, and that single point where the line touches the circle, it is called the point of tangency. On the other hand, if a line touches the circle at 2 points, then that line is called a second line. A second line to the circle always contains a chord. Next, we have to discuss the angles related to a circle. If an angle is drawn such that the vertex is at the center of the circle, we have what we call a central angle. This angle gets its name from the vertex being at the center, hence central angle. The sides of a central angle are 2 radii of the circle. 2 chords or 2 lines intersecting inside the circle will also form an angle. This next angle here is formed with its vertex located anywhere inside the circle but not on the center. This one is called an interior angle. Its sides are formed by 2 lines passing through the circle or by 2 chords which intersect inside the circle. If an angle is drawn such that the vertex is located anywhere on the edge of the circle, it is called an inscribed angle. The sides of an inscribed angle are 2 chords of the circle. I hope you see the differences among these angles. All you need to take note is the location of each vertex, and then you're good to go. Okay, we're halfway through, but we still need to talk about one more important element of the circle. It's called the arc. I would like to bring back a line in order for you to better understand what an arc is. Remember, if we cut a line removing its arrowheads, we get a portion or part of a line which we call the segment. It's the same concept on a circle. We only get a portion or part of a circle, we get an arc. An arc is a part of the circumference of a circle. Just like how we divide a single line into several segments, we can also divide a circle to get several number of arcs. Now, let's bring in a new circle. If we divide a circle by drawing a diameter, we get 2 semicircles. A semicircle is literally half a circle. We will now use the semicircle as a reference in identifying the next 2 arcs. Any arc smaller than a semicircle is called a minor arc, and any arc greater or bigger than a semicircle is called a major arc. Remember, minor, small, major, big. One last thing. If an arc is contained between the sides of an angle, like for instance, this arc inside the central angle, this arc inside an interior angle, and this arc inside an inscribed angle, is called an intercepted arc. The name came from the arc being intercepted by the sides of an angle. That may be a lot of information to take, but you can always repeat watching this video if you need a recap. Now it's time to check what you have learned about circles. And today, we will do the fast talk. I'll give you 2 options for each question. All you needed to do is give your answers as quickly as possible. Choose wisely to get the correct answer. Are you ready? Let's do fast talk. Center or middle? Radius or diameter? Secant or tangent? Point of tangency, A or B? central angle or inscribed angle. Diameter or secant. Minor arc or major arc. Semicircle or major arc. Yes or no? Diameter is twice the radius. Yes or no? A tangent contains a chord. Yes or no? The diameter is also a chord. Chord or radius. Which is bigger, semicircle or minor arc? Yes or no? A semicircle is 1/2 of a circle. Chord or secant. Last question. Inscribed angle or interior angle? Thank you for doing Fast Talk. Have fun learning. See you in future videos. Congratulations for finishing another lesson. I have posted a link for short quiz down in the description. Sign in anytime to assess what you have learned about circles. Good luck and thanks for watching. I'll see you next time.